through with the advanced lessons for Grade 8, Week 1. We are now moving forward with the advanced lessons for Grade 9, Project-led Learning Modules. To introduce our speaker, she is a graduate of Philippine Normal University, Isabela Campus, with a degree of Bachelor of Science in Education, major in Mathematics. She finished academic requirement at Eulogio Amang Rodriguez Institute of Science and Technology with a degree of Master of Arts in Teaching, major in Mathematics. She worked for 5 years in Arellano University. For 15 years, she served public schools, and currently, she is a teacher at Highway Hills Integrated School. Without further delay, let's welcome Mrs. Zoraida L. Cruz.
Thank you, Ma'am Karen. Once again, I'm Mrs. Zoraida L. Cruz, Grade 9 teacher at Highway Hills Integrated School. We are going to review Grade 9 Clyde Module, Quarter 2, Week 1, Topic Variations. Our objectives. 1 is to illustrate situations that involve the following variations: direct, inverse, joint, and combined. Second, to translate into variation statement a relationship between two quantities given by table of values, a mathematical equation, graph, and vice versa. So what is variation? It is a mathematical concept where two variables may be related in such a way that if one of the quantities increases or decreases, the other quantity also increases or decreases in a definite way. Variation may be classified into 4 types: direct, inverse, joint, and the last but not the least, combined variation. We have here now the first type of variation. It is the direct variation. It can be described as a relationship between two quantities, x and y, such that as x increases, y also increases, and as x decreases, y also decreases. So it is also a variation in which the quotient or ratio of two variables is constant. Then we say y varies directly with x. In symbols, we write as y is equal to k times x or k is equal to y over x, where k is the constant of variation or constant of proportionality. Read as y varies directly as x, wherein y is directly proportional to x, wherein y is proportional to x, or y varies as x. How to write the following relationship into equation, where k represents the constant of variation. 1. The cost of chicken varies directly as its weight. So the two quantities here given are C, cost of chicken, and W for the weight of chicken. So we write as C is equal to K times W, or K is equal to C over W. The circumference of a circle varies directly as the length of its diameter. The two quantities given, C for the circumference, D for the diameter of the circle. So we write as C is equal to K times D, or K is equal to the ratio between the two quantities, C over D. 3. Water pressure varies directly as the height of the water. So we have the two quantities, P for the water pressure and H for the height of the water. So we write as P is equal to K times H, or K is equal to P over H. Okay, so we try to relate the direct variation into a problem. So we have here, using his bicycle, Jericho travels a distance of 10 kilometers per hour on a steep road. How many kilometers would he have traveled in 8.5 hours? So we have here the steps in solving. Step 1, write the correct equation. 2, use the information given in the problem to find the value of k. Step 3, rewrite the equation from step 1, substituting in the value of k found in step 2. And the last, but not the least, use the equation found in step 3 and the remaining information given in the problem to answer the question asked. Let's apply now the following steps. 1. So we are going to write the equation. So since the distance d varies directly as the time t, then the relationship can be translated into a mathematical statement or equation as d is equal to k times t, or k is equal to d over t. Step 2. So, use now the information given in the problem to find the value of k. So, gagamitin natin yung equation ng in terms of k, which is equal to d over t. Okay. So, since the first value of the distance is equal to 10 kilometers per hour, so the value of t is equal to 1. So, we substitute 10 divided by 1 is equal to 10. So, that is the value of the constant or k. 3. Rewrite the equation from step 1, substituting the value of k found in step 2. So we are going to use the first equation given, which is the d is equal to k times t. So we just substitute the value of k, which is equal to 10 times t. So ito ngayon ang gagamitin nating equation para ma-solve yung tinatanong dun sa problem or yung bagong distance given the time. Step 4. So we are going now to use the equation found in the step 3 and the remaining information given in the problem to answer the question asked. So yung tanong kanina sa problem, how many kilometers would he have traveled in 8.5 hours? So again, we use the equation in 3. D is equal to k times t. Then the value of k is 10 times t. Okay. So 10 times the value of time is equal to 8.5, or we can use 8.5 times 10 is equal to 85 kilometers. Given the table that shows the distance he has traveled at a particular length and time. So time in hours, t, distance in kilometer, d. So makikita natin dito, yung mga values ng time increases, same through with the distance in kilometer increases. So both of the time and distance increases. So if the distance varies directly as the time, then again, we translate the mathematical statement as 1, k is equal to d over t, or distance over time. So, kung i-divide natin yung mga set of values ng distance over the time, we have 10 over 1, which is equal to 10, 20 over 2 is also equal to 10, 30 over 3 is equal to 10, so on and so forth. So, this is the constant ratio. 2. So, if we use d is equal to k times t, then we substitute the value of k, 10, to find the this unknown distance where time is given 8.5 hours, or 8.5 times 10 is equal to 85 kilometers. Now, if we plot the following points in the graph, you can see that the graph of direct variation is a straight line. So we have here time in hours, t as the value of x, distance in kilometer, d as the value of y. So we have here the coordinates 1 and 10, 2 and 20, and 3 and 30, 4 and 40, and 5 and 50. We have also the so-called direct square variation. It is a relationship between two variables, x and y, such that the ratio of y to the square of x is a constant. So, dito sa direct square variation, magkakaroon ng square ang second quantity or the second variable x. Statement, y varies directly as the square of x, written as y is equal to k times x squared, or k is equal to y over x squared, where k is a non-zero constant of variation, read as y varies as the square of x, or y is directly proportional to the square of x. So, how to write the following relationship into equation where k represents the constant of variation. 1. The price of a diamond varies directly as the square of its mass in carats. So, the two variables here or quantities given. So, we have the price represented by P, mass represented by M. So, we write P is equal to K times M squared, or K is equal to P over M squared. 2. The kinetic energy of a moving object is directly proportional to the square of its speed. The two quantities here, E for energy, V for speed. So we write E is equal to K times V squared, or K is equal to E over V squared. The length of a pendulum is directly proportional to the square of the time it takes to swing from one side to the other. The two quantities given, L for the length of the pendulum, T for the time. So we write as L is equal to K times T squared, or K is equal to L over T squared. Again, let's relate direct square variation into a problem. The cost of pizza varies directly as the square of its radius. If a pizza with a 6-inch radius costs 8 pesos, how much should a pizza with an 11-inch radius cost? So the two variables or quantities here, C for the cost of pizza and R for its radius. So we are going to use the following steps again in solving. 1. Write the correct equation. So we write C is equal to K times R squared, or K is equal to C over R squared. Step 2. Use the information given in the problem to find the value of K. So K is equal to C over R squared. The first value of circumference is 8. For radius is 6. Then we square. So that is equal to 8 over the square of 6 is 36. The constant is 2 over 9. 3. Rewrite the equation from step 1, substituting the value of K found in step 2. So we use now C is equal to K times R squared. Then we just substitute the value of K, which is equal to 2 over 9 times R squared. Step 4, we have to use now the equation found in step 3 and the remaining information given in the problem to answer the question asked. So C is equal to K times R squared. Then the constant is 2 over 9 times the new value of the radius, then square. The new value of radius is 11, then square. So that is equal to 2 over 9 times the square of 11 is 121. Then we multiply 2 times 121 is equal to 242 over 9. Then we divide 242 divided by 9, that is equal to 26.89. The next type of variation is the inverse variation. It occurs whenever a situation produces pairs of numbers whose product is a constant. So indirect variation, the constant is the ratio between the two quantities, while in inverse variation, the constant is the product of the two quantities. It can be described as a relationship between two quantities, x and y, such that as x increases, y decreases, and as x decreases, y increases. So indirect variation, both of the values of x and y increases or decreases. In symbols, y is equal to k over x or k is equal to x times y, where k is the constant of variation or constant of proportionality, read as y varies inversely with x, or y is inversely proportional to x. So how to write the following relationship into equation, where k represent the constant of variation. 1. The amount of time traveled when driving a car varies inversely with the car's speed. The two quantities here, t for the amount of time and v for the car's speed. So we write t, which is equal to k over v, or k is equal to t times v. The cost for a field trip varies inversely as the number of students joining. So the two quantities, C for the cost of field trip and N for the number of students. So C is equal to K over N, or K is equal to C times N. 3. The time it takes to paint a room varies inversely as the number of men to paint. So the two quantities, T for time and N for the number of men. So we write T is equal to K over N, or K is equal to T times N. Now, let's relate inverse variation into a problem. The number of days in repairing a house varies inversely as the number of men working. It takes 15 days for 2 men to repair a house. How many days to complete the job if there are 6 total men working? So again, we are going to use the following steps in solving. So the two quantities here, the number of days represented by D and the number of men represented by N. So we write the equation as D is equal to K over N, or the constant is equal to the product of the two quantities D and N. So we use the information given in the problem to find the value of K. So in terms of K, that is equal to D, or the product of the two quantities. First value of days, 15, and number of men is 2. To complete the job, which is equal to 30. That is the value of constant. 3. Rewrite the equation from step 1, substituting the value of K found in step 2. So the first equation, D is equal to K over N. We substitute the value of K, which is equal to 30. So that is now D is equal to 30 over N. Step 4. So we can now use the equation found in step 3 and the remaining information given in the problem to answer the question asked. So D is equal to the value of constant over N. So the value of constant is equal to 30, and the new value of number of men is 6. So how many days to complete the job? That is equal to 5 days. The table now shows the number of days and the number of men working in a house. So I have here the number of men. As you can see, it increases and the number of days decreases. So the constant here is equal to D times N, or the product of days and N. So we have 15 times 2, 30. 6 times 5 is equal to 30. 5 times 6, 30. 2 times 15 is 30. And then the last is 1 times 30 is equal to 30. So the constant product of D and N is equal to 30. So if we are going to graph the following points, we can see that the graph of inverse variation is a curve. It is called hyperbola. So when we say hyperbola, it can never be passed through the origin of the graph. So we have here the number of men as the value of x and the number of days as the value of y. The next type of variation is the joint variation. It occurs when one quantity varies directly as the product of two or more other quantities. It is a variation in which the quotient of a variable and the product of two or more other variables is a constant. In symbol, we have y is equal to k times x times z, or there exists a non-zero constant k, where k is the constant of variation or constant of proportionality, read as y varies jointly as x and z. Examples on how to write the relationship into equation, where k represents the constant of variation. 1. The area of a parallelogram varies jointly as the base and altitude. So the three quantities here are A for area, B for the base, and H for the altitude. So as you can see, not only two quantities are involved, but there are two or more quantities. So we write as A is equal to K times B times H, or K is equal to the area over the product of the two quantities, base and altitude. 2. The force applied to an object varies jointly as the mass and the acceleration. The three quantities here, F for the force and M for the mass, and the last is A for the acceleration. So we write F is equal to K times M times A, or K is equal to F over M times A. 3. The volume of a cylinder varies jointly as its height and the square of the radius. The three quantities here, B for the volume, H for the height, and R for the radius. But take note of the square of the radius. So we write V is equal to K times H times R square, or K is equal to V over H times R square. Okay, so let's relate again into a problem. The area of a triangle varies jointly as the base and height. If the area is equal to 65 centimeters square and base is equal to 10 centimeter and the height is equal to 13 centimeter. Find the area of a triangle given the base 8 centimeter and the height of 11 centimeter. Again, we use the steps in solving. The equation A is equal to K times B times H, or K is equal to A over the product of base and the height. 2. So we use the information given in problem to find the value of K. So in terms of K, we have A over BH. The first value of area is equal to 65 centimeters square over the product of the base, 10 centimeter, times the value of the height is 13 centimeter. So we multiply first the product, the value of the base, 10 centimeter, and 13 centimeter. So that is equal to 130 centimeters square. So we divide 65 centimeters square over 130 centimeters square. So we cancel centimeters square and we reduce 65 over 130 into its lowest term, that is 1/2. So the constant is 1/2. 3. So how to write the equation from step 1? Substituting the value of K in step 2. So we have here now the equation A is equal to K times B times H. The value of K is 1/2 times B times H. So we use now the equation in solving the remaining information given the problem to answer the question asked. So we have to substitute the value of k, 1/2 times b times the height. So 1/2 times the new value of base is 8 centimeter, and for the height, 11 centimeter. So we have 1/2, and then 8 times 11 centimeter is equal to 88 centimeter square. So 1/2 times 88 is equal to 44 centimeter square. The last type of variation is the combined variation. It is a kind of variation that involves both the direct and inverse variations. It is a variation in which the quotient of the product of two variables and a variable is constant. So from the word combined, it is a combination of the direct variation and inverse variation. In symbols, we write y is equal to k times x over z, or k is equal to y times z over x, where k is the constant of variation or constant of proportionality, read as y varies directly as x and inversely as z. Examples, write the following relationship into equation, where k represents the constant of variation. 1. T varies directly as A and inversely as B. So T is equal to k times A over B, or k is equal to T times B over A. 2. The pressure of a gas varies directly as its temperature and inversely as its volume. So the three quantities here, P for pressure, T for temperature, and V for the volume. So we write P is equal to K times T over V, or K is equal to P times V over T. 3. The monthly sale of a company varies directly with their advertising budget and inversely with the price of the product. The three quantities, S for monthly sale, A for advertising budget, and P for the price of the product. So S is equal to K times A over P, or K is equal to S times P over A. Example, if y varies directly as x and inversely as z, and y is equal to 22 when x is equal to 4 and z is equal to 6. Find y when x is equal to 10 and z is equal to 25. So we write the equation y is equal to k times x over z, or k is equal to y times z over x. So use the information given in the problem to find the value of k. So we use k is equal to y times z over x. First value of y is 22. For z is 6. Then the first value of x is equal to 4. So we multiply 22 times 6 is equal to 132. Divided by 4 is equal to 33. So the constant is 33. So rewrite the equation from step 1, substituting the value of k found in step 2. So we use the equation y is equal to k times x over z. Since our value of k is equal to 33, the equation now is equal to y is equal to 33 times x over z. And then 4, we use again the equation found in step 3 to answer the remaining in the problem. So y is equal to k times x over z. Constant is 33 times x over z. So 33, the new value of x is 10, and for z is 25. 33 times 10 is equal to 330 over 25, and that is equal to 66 over 5. So we reduce 330 over 25 into its lowest term, that is 66 over 5, or that is equal to 13.2. That's all. Thank you and God bless.